Yeah. Who does? Matt. What?
Daniel,
Did you say Putin?
Did you say Putin?
I didn't say Putin.
Oh, okay. I thought you said Putin. I'm like,
Well,
It's got some interesting selective hair.
what's just what it
actually,
sounded like?
I actually don't. I'm not doing that most.
Huh?
The green does get weird.
Yeah, that's it. The chemicals.
Okay, so who needs co-host? Do you want it? Yes.
All right, is anyone still waiting on the QR code for sign in? No? Got anyone in chat that still wants to sign in? Guessing that's a no. Cool. All right. Continue on then. So just want to welcome everyone to the meeting. We got some great stuff for you. We're going to be covering search engine weaponization and some more OSINT stuff. Should be pretty cool. Once again, gonna give you all the opportunity to grab this QR code one last time. Not gonna leave it up for that long, just like maybe a minute or so, just in case anyone's joining in chat that hasn't had a chance to. Everyone have a good week? So any crazy thing happened? Good stuff, bad stuff? No? Fun. Yeah, love compliance. Sounds like work.
Mark is compliant. If you don't want to, then that's fine too.
Yeah, do this one thing unless you're not going to need to do it.
I mean, honestly though, most businesses are what?
We can just sit it.
Who needs compliance? Like, just don't tell the authorities.
Yeah, it's compliant, so I have to prove it, right?
Yeah,
Fine, right? Yeah.
totally.
Do you have any proof? Well, I thought.
That sounds like,
Yeah,
Pretty good talk.
it's just compliant. We don't need an audit. The audit is I say so.
Audit who?
Exactly.
I know about. What's an audit?
yeah, we had an audit, an internal audit. It's good.
Yeah.
Yeah, and it was 10 seconds long.
Yeah,
Doing audit is ourselves, I don't know.
We have not done anything wrong.
The audit process, okay. We're fine.
all right. So gonna go ahead and move on. Today's topics. So we got the previous week's cyber challenge solution we're gonna go over. I hope y'all enjoyed that. It took me a little while to make it, so we're gonna go over it. We got current events with Oreo Meister, which hopefully they are in the chat because I do not see them here. We got tool time doing some audio steganography with Jackson, and then our main event we are doing search engines and OSINT with Sugar, Jackson, and myself. And then we're going to just go ahead and wrap up with closing. First, we got some announcements. The NSA code breakers. This is still going on. We are still plugging this. We still want people to get involved. If you haven't gotten a chance to do it, maybe you've been busy with school, maybe you got busy with midterms, maybe just like weren't really sure yourself. You've been picking up skills all along the semester, and now you're ready to get in and do this. You definitely can. It's going to continue running until December 31st. So, yeah, what's up?
They extended that to January 4th today.
Yes.
Oh, fantastic. Good news. Extension to January 4th. So I get even more time. The top 20 schools get recognized. The the top school gets an on-site visit. And that would be really cool if it was us, because I'd love to pick their brains on some of the stuff. Tasks 1 through 6 can be a team effort. So if you aren't really sure of yourself, or you just don't know really where to get started, or maybe you like have been doing it and you get stuck, we can answer questions. We can help you out with that. And also for every challenge that you complete, you get a little badge to recognize the efforts that you're doing. So that's also super cool. Go on your LinkedIn or something. Next, we got Hack the Box, the Uni CTF. I'll let Jeffrey talk about this a little bit.
Sure thing. So the Hack the Box University CTF is a Jeopardy style CTF run by the folks over at Hack the Box. We have 10 slots. Most of them are pretty much filled, but a few current participants have mentioned interest in like vacating their spot if someone is interested in taking on the role. Challenges, sorry. They range from pretty easy to very hard, including stuff like web, crypto, reverse engineering, cloud, hardware, miscellaneous, SCADA, and more. So whether you like cloud computing, OT, or just good old classic Pwn, there's most certainly something for you. I think last year they had a blockchain challenge as well. There's a prize pool up to 22,000 pounds, which also includes donations to Khan Academy, as well as various levels of subscriptions to Hack the Box and Hack the Box Academy. You can win Hack the Box goodies, merch, VIP plus, as well as some other things, including cash. And if you're interested in participating, you can reach out to me, Sugar, or Ratman, if you're interested in participating. Only a few slots remain, and if you are wanting to kind of take one of those slots, you're going to be replacing someone who doesn't want to compete. So make sure you're willing to compete when the competition is on the 19th.
And then we got the NCAA C2 games. These are still kind of in limbo. I think we're waiting to hear back a little bit more on some specifics here, but if you haven't had a chance, please go and sign up, show some interest. I think they're basically just waiting on enough people to justify having the competition at all. So should be pretty beginner oriented. They say no experience needed, just willing to learn. And it is free to participate, open to everyone. You can get that at c2games.org or grab this QR code here. All right. Next up, we got Blackstone security internships. Jeffrey, you actually have some experience with them.
So yeah, I actually was at Blackstone last summer as a security analyst on the SecOps team, and they're looking for a lot of new positions. They've recently massively expanded their cybersecurity presence now that they have an office down at Miami. They just finished building it. It's pretty nice from what I've heard. So there's positions like security engineering, cloud security, security operations, which is the division I worked at. Some really cool folks over there, as well as network security, portfolio security. So since Blackstone has several portfolio companies, you'll be able to be on a team where you work with some of their assets in order to protect them, such as Great Wolf Lodge, Custom Ink, which we actually use for our hoodies, and more. There's going to be a hiring session with the CISO, Adam Fletcher, on November 17th from 5 to 7 p.m. Eastern time, but RSVP is required. You can scan the QR code or type in that URL and it'll redirect you that way. As far as just kind of my personal experience, you get to work in a cloud native environment, relative flexibility. They're relatively chill and they just migrated a bunch to cloud. So you might be having some fun in a cloud native environment in one of the world's alternate asset management firms. If you have any questions about this internship or my experience at Blackstone, feel free to reach out to me. I'll be more than glad to answer your questions or try to point you to someone who can. Now,
awesome. So design competition, let y'all know that this is wrapping up in about 2 weeks. You've got until the 25th of November to submit. You don't need to wait to the end. If you have a submission that you want to drop, go ahead and drop it. If you want to wait, you can, but just remember, if your submission comes in on Friday, the 26th, it will not be counted. So need to keep in mind with that. We have hammered out some final details on the prizes, and we're going to talk about that a little bit today. But if you are looking for templates and logos, you can go to hackucf.org/shirts. When you're submitting, drop it at shirts@hackucf.org. Don't use other people's stuff that you don't have permission to use. You can go to this. Wait, never mind. Don't go there. That's from the voting, and if that's closed. But we did vote for prizes last week, and what you get is a copy of whatever you design. So if you design a hoodie, you get that hoodie. If you design a t-shirt, you get that t-shirt. And if you design some other merchandise, a hat, bottle, flip-flops, I don't know, sticker, you get that too. In addition, you also get one $100 gift certificate to Hack5 for any and all of your hacking tools. and you get a set of lockpicks. We are still determining exactly what set of lockpicks you're going to get, but most likely it's going to be something by Southord. So nothing exorbitant, but should be pretty cool, especially if you like picking. All right, so did anyone actually solve the cyber challenge this week? Did anyone try it? Yeah, got a couple of people. Okay, awesome. So don't hate me, but we're gonna go through this. This, if anyone isn't familiar with it, was inspired by a challenge, a challenge badge from DEF CON a couple of years ago, and I wanted to do something similar to it, but this is not at all the same path that went down. I just kind of like took the inspiration. So we're going to jump into a couple things. We're going to go through what I designed as logical leaps and why I thought that you should have enough information. So first thing that you need to do, right, is to recognize that every single color corresponds to a unique identifier. If you looked closely at the image, you'd be able to tell that in the top and bottom bar, all of the blocks were actually showing you numbers. So red is 0, orange is 1, yellow is 2, green is 3, blue is 4, and purple is 5, right? You got 6 colors, 0 to 5. What I started with is just realizing that like each color corresponded to a letter, right? Just to like designate all the different colors. Then we would take those colors and we would, match them to the numbers that they existed in the panels. So orange or O becomes 1, red becomes 0, and you get these sets of numbers. Next thing you need to do is to pull all of those numbers off of the card and recognize that the numbers are essentially separated by blank spaces, right? The white, literally white space. But you got all this and you don't really know what to do with it. There's a couple of things going on here, but like, let's jump in a little bit and start cooking with some Cyber Chef. So what we're gonna wanna do is take this from the output that we got and format it a little bit easier into a string of characters that is not broken down by a new line. Then what we'll do is we're going to use the fork operator. And what that is going to do is it's going to apply a separate operation for each set of characters instead of trying to do a transform on the entire operation. This lets us do things like change character typing from like one classification to another classification without assuming that the entire string of numbers is just one number. So one of the things you might have noticed is that in all of these numbers, there is not a number that goes above 6. That's a good clue that what you're dealing with is something that is not in base 10. So making the assumption of from base and just rolling through the radix will bring you down to base 6, which is like not as common of a base to be used, but is still used for some things. We still have zeros, however, and I just want to like get rid of those because they were kind of annoying me. It should be kept in mind that like you can do all of these operations without needing like a computer. It just kind of like makes it faster and easier to like play around with things, which is why I love Cyber Chef. You should be able to do the entire challenge by hand. Recognizing that zeros are a representation of white space, we remove those, and so we've got more numbers, and it looks like we're definitely like breaking above a threshold. We're like recognizing that like we have everything that is a 3-digit character, and these like kind of sort of maybe look like some kind of formatting. They might look like ASCII, so let's like kind of investigate that. Unfortunately, ASCII only goes up to 127. So we have several numbers, 226 and 160 that definitely, these are not ASCII numbers. But we can do from char code, and it basically tries to make an assumption of what it is that you're looking at. And in this case, it wasn't ASCII, but it was Unicode. And that Unicode outputs these characters. And you're probably looking at this and recognizing what it could be. And it is certainly Braille. You do from Braille and you end up with a flag in plain text. And we can clean that up a little bit further. And what you end up with is illegal rainbows go to prison because puns are great. And now we're on to current events.
Cool. So has anyone been paying attention to the news?
No.
Cool.
Now you are.
Yeah. Yeah. So basically, SolarWinds, they're getting sued. Can anyone guess why? Yeah. So they had the SolarWinds, the big SolarWinds breach happened a couple years back, or a year or so. Time flies. Anyway, so basically they're being sued on the premise that SolarWinds failed to implement procedures to monitor potential risks and failed to report those potential risks. And when I was reading through these articles, I found that one security researcher mentioned that he was able to access the update server, which caused the entire breach with using the password SolarWinds123, and they apparently might have not fixed that issue. And the suit also alleges that SolarWinds made misleading or false statements with the vulnerabilities that could have been there. And they're also upset that they lost a lot of money when the stock crashed after the breach, which happens with every company. So that's some common things. But yeah, they're getting sued, and we'll see. We'll never know what happens with that because it takes a while to get sued. Furthermore, sorry,
Where are they getting sued by?
say it again.
Like, who's actually bringing up the lawsuit against the SolarWinds?
There's just a bunch of investors mainly.
Are they individual lawsuits or is it class action?
I think there are a bunch of individuals that are going to get merged to one. But in any case, Robinhood also got breached. Fun. So according to Robinhood, 7 million people got affected by this. 5 million emails were leaked and 2 million people's full names were leaked. And unfortunately, the 300 people, their birth dates and zip codes were also leaked in accordance to the emails and full names. No banking information was leaked, nor no money was taken from the accounts in Robinhood. So like people maintained their stocks. And they were basically ransomed and they didn't pay it. So that's good on them because you don't want to give the attackers money. And then another one is a cybersecurity infrastructure bill from the Congress and the government. $1.9 billion. There's a lot of things that goes towards, but I didn't want to bore you with all the details, so I kind of summed it up. 1 billion goes to state and local governments for a grant. Energy, like the entire, I guess, U.S. Energy or Department of Energy gets 350 million to basically make more grid securities and improve their security posture. And then water gets a lot too, just in case their infrastructure is getting attacked, because water, we all need it. So they're getting a lot of money to that. They also get 175 million to emergency grants in case they are breached and they need to spend money to fix it immediately. Obviously, it's not comprehensive. Bills are really long, and I don't have the time, nor does anyone really have the time to read the entirety of it. So,
What are you talking about, Matt? Like, make the time.
no,
Bet
Yeah.
you also don't read terms of service, do you?
Oh, man.
I can't say or not.
Hey, like, you can argue that it's not legally binding. You shouldn't read it.
Yeah, read the terms and conditions. But yeah, that's all for current events.
Awesome.
Cool.
Thank you, Matt.
All right.
All right. So Tooltime is back, and this week we'll be going over audio steganography.
I might need that. I also might need to be able to play sound from this.
Oh,
Finish
yeah,
stream the video.
there's a HDMI cable.
Yeah.
And then we'll just transfer you over to. Yeah.
I was already in Zoom.
Awesome. Cool stuff. You got co-host?
No, I did not.
Jeffrey, can we get him co-host?
Name?
Jackson?
1 sec. I have to click host. You're now co-host. And you're good.
All right, cool. Let me share my screen button. Where is it? No. Oh, not used to.
Do you have a HDMI?
No. Where is it?
I might.
I gotta make sure this has HDMI cable.
Yeah,
might not
I do have an
HDMI
HDMI
port.
cable.
Crap, I don't think I have an HDMI port.
Wait on the HDMI port.
Rip.
Just share screen.
I can.
Yeah, just go ahead and, you got photos, go ahead and just share your screen.
Okay. There it is. So screen,
What do you think?
yes, screen's fine.
There you go. And then you'll need to share sound. You click
Yep.
more.
Cool. Share sound.
There you go. Cool. So now.
Right,
you should
cool.
be broadcasting.
Don't know if this is gonna overlay, but yes, so for now, we're just doing. Oh, yeah, Dang. That's me. I turned this up.
Yeah, you should be able to like bring it up, just not that loud.
Mute yourself in the Zoom call.
Oh, yeah.
Yes.
I am. It's because I'm sharing computer audio. Should
You can
work?
actually set down the microphone over here. All right, I've turned down the output. Bring up your audio. Go ahead and
How's that sound?
a little bit back.
Should be fine. Okay, so
They were just talking about like, talking about English there, but. Oh, good idea.
His Zoom is muted.
My computer. Here. What? Okay. This isn't gonna like me because of how we have this set up, but this should work a little better. So audio steganography is different than image steganography because it involves hiding hidden messages, images, a lot of other different things inside the actual wave format of any kind of audio. So they can be used, a variety of different programs can either be used to accomplish hiding an image, seeing the image, or finding any other message. Audacity, open source, free software, a lot of people know what that is. You can use that to do this. Sonic Visualizer, I'll explain why later. And then a lot of this you can just do with simple Python scripting, just to hide messages in it. There are a lot of different ways that you can hide them. There's LSB, least significant bit, that you can use to hide like text or links or anything in the actual binary of the file itself, which has an effect on the audio. There's SSTV, slow scan television. That converts like some kind of image into a wave, which, fun fact, the Apollo missions actually did this to send images back to Earth because it was the most efficient way to do that at the time. And then there's also FBM, frequency-based modulation. And that's basically setting an audio to an inaudible frequency, merging it with another audio source and concealing it into another. So let me just get all this out. Start with first example. Here. All right, examples. So probably one of the more fun examples that I can show would be this one. Let me open this with. Never mind, I'm just not going to do that. So. I don't know how well some of you can hear this. Let me. Yeah, so that's soundtrack from Doom from about what was it? Yeah, that was Yes. I did forget to mention that. That's what I should. Okay. Never done this before. My bad. First time.
Sorry for those on Zoom
So, yes.
who had their ears destroyed.
Congratulations, you're gonna get a lot of that today because audio stego is generally going to be very loud and how it affects audio is gonna sound weird. So we heard what that sounded like, but we can actually view a hidden image in it with Sonic Visualizer, which is what I like to do to view this. So if we open that file, desktop, here, find the file, Cyberdemon. This is the soundtrack. When you own Doom, you can strip this and find it yourself. This is what it actually looks like. Like this is just the sound frequency, but they did actually conceal images inside. So a spectrogram, if anyone knows what this is, basically converts wave formats into images or like light. So if we add that to this whole thing, we get this really weird looking, this green contraption. You can, I like Sonic Visualizer because I can change all the colors to what I want. So I'm going to change it to sunset, make it look like this, because it'll show it better. So I know exactly where I'm supposed to look. I go to around here, should start to see it. See, like Doom being Doom, health theme. You got like a bunch of pentagrams hidden inside as images. They got 6s. And what was really cool about it was if you listen really closely, I don't know how well I can show it here, but if you're listening closely, they actually make these images mix with the audio. So it sounds like it's a natural part of the soundtrack, even though it's just added indirectly. So really cool fact that it was just kind of, they hide this in all their audio. So that was their one version. I got another version. Which one do I want to show next? I can open this one. So we're just going to play this audio next. Don't know how well this is going to work. Again, but this is the little level. Okay. Anyone who can hear, Zoom here, probably you guys can't. I have September playing Fire 25. You can't really hear what's different about it, but compared to if you have the original song and if you have this in a better quality, you hear a little kind of fuzz in the background of this, which isn't a normal soundtrack. So if you wanted to, this uses the least significant bit method, adjusts all the binary and this is edited. We can view actually how this affected the original look. Open this back up again. We open actually this one, and we view it over spectrogram again. All of these look awful. See how like it's so much brighter than the regular. If we open the original, which I have on here. Beep. No, don't say that. Layer, spectrogram. This. There's not any of that really high frequency green that's affecting it. When you change the binary of file, it's going to do that. So changing the binary itself is going to do that. So I did have a program I wrote. CD, desktop, technography. Here. I'm just going to move some things around. I need this. Oh, no, move this here. Move into here. So we're going to use Python. This is a script I wrote. I'll show this later what I exactly did. We're going to give it the input of September. What do I call this? Stego.wav. So if we run this, Kelly does not like me. Why don't you?
Just ask, probably say please. Just say please.
Yeah, please do this. UTI code. Oh, I hate when I don't prepare things correctly and sometimes it doesn't work. This is my apology. I'll show the code and how it's supposed to actually work, but I hid inside like the lyrics like do you run the 21st night of September. This basically just hides in the least significant bit of the audio. It takes the original audio file, takes the entire binary, like we'll decode the entire thing into the raw binary, take a string you give it, convert that into binary, and add that all of the least significant bit of the other. Then merge that together and save it as a new file. So that's why the other looks like that. So a little weird because that to not work the way I wanted, but that's okay. Another one, a favorite of mine.
A new hand touches the beacon.
Any of you play Sky?
Touches the beacon. A new hand touches the
If someone would give it. Just the loop of a new hand touches the beacon. So for this one, this uses kind of like the slow scan TV image. If we open this up, where'd it go? Beacon. looks horrendous. We layer a spectrogram on top of it. We zoom out. It's a little weird to see, but that's where changing the color comes in. Adjust that. Pretty sure blue on black honestly shows up the best. I literally just put an image of Maria's beacon in here, like the actual rocket that is just in an audio asking. So you can hide images, you can hide text. Python worked on this, and I prepared that. Would be able to show the decoding. There's another thing that you can use Audacity for. So I've shown it. You can hide images in it. You can find images in the spectrogram. You can hide things in the raw binary. You can actually hide entire audio inside of another outside the audible frequency. So retail.wav. And a little hard to hear, but I have a loop coconut mall playing. Yes, absolutely perfect. We have that running. So let's just take a look at that in Sonic Visualizer and let's just see if anything shows up in the spectrum. Let's take retail layer, let's add a spectrogram, see if anything's in there. So nothing is in there, but you notice there's the regular sound that it's normally there, but really up high, there's a whole nother weird color that isn't an image, it's not anything. It's at a high frequency, it's above 20,000 hertz, which is outside the audible range that humans can hear. So that is actually hidden audio that you can't hear, but is also playing at the same time as Coconut Mall. So this might not work. So this is where Audacity comes in. If two of these view this. Yes, no, I don't want to start. Okay. Beep, file, open. No. Here. Retail. So Audacity is a little difficult to use, but it's really useful for a lot of different reasons. They actually have their own custom scripting language called Nyquist. Pretty sure it runs off an extension of Lisp. So if I select this whole audio, I just have a little script that I can do. So we know something's at a high frequency. We can go to Tools. We can go to a Nyquist prompt. And we're gonna load, oops, it's not in there. Here. These are .ny files, Nyquist prompts. So this is the receiver. So this is just one simple command that's basically lowering everything down to a regular frequency, 17,500, but I didn't do that. We're gonna do it by 20,000 because that's where it was. If we, Yep, it's applying the Nyquist prompt. So it might be a little difficult to hear again, but some people might be able to hear it better. It's really annoying. This is for me here. Why? Yes, I am a monster. Anytime you think a retail store is playing Christmas pizza too early, they're not. It's always there. It's just hidden outside. You can actually hear it. It's always there. It's never not playing. You should know this.
Damn you, Mariah Carey.
So you can hide all sorts of things in the binary, in a text message. You can hide images. You can hide actual audio files outside the audible frequency. Hide literally anything if you know how waves work, basic waveforms. So show how all that worked. Take time to show how most of that worked. Cool. So
I'm interested. I think everyone else is doing.
so I have a couple Python files. Maybe I just didn't install pip. Imagine like that down with the reason that's not working. Python file, open. I'm not sure. All right, anyways, I have the actual script I wrote to convert the text to the binary one. That's all this. Alrighty, so basically convert to binary, you just have to have a basic understanding of the wave library and how binary works. So you're gonna ignore all this parser stuff because this is just how to run it on command line, so I could do it. The encode decode is actually where most of the stuff happens. So there's the encode and the decode options. So for encoding, when you give it whatever input song you have, it's just gonna convert that. It's gonna open up the file, make sure it can read it. And then this line, frame bytes byte array, this is going to take the song and convert it's gonna get all the frames from it with input song.get end frames and input song.read frames. Gonna condense all those frames into a list and then make it into a byte array. And then it's gonna take whatever message you gave it, convert that, add length to it. You have the length of the message and the length of however many bytes were in that other array. So you have your regular message. This line is adding a bunch of default characters because you're adding to the binary, but there's also a ton that you probably aren't going to use. So it adds just a bunch of this to the end, just as like defaults. That way the binary all lines up correctly and everything's done correct. Now this converts the entire message. So this full message here, this converts it into the actual bits, the whole binary. Just converts it all into that. And then once it does that, it's going to run through this loop where it's going to take the the byte array, that's just all the bytes, and it's going to add in all the bits from the message you got. It's going to add in like to the least significant bit. It's going to add it all to the end. Then it's going to resave it as a modified, and it's going to, and then it's going to resave it as a totally new file. So you have your original file that's completely unedited, and then you also have the new file that has that mixed into the actual binary. So if you were able to like pull the least significant bit from the binary of the actual file, you can decode it by turning the last thing into the binary, convert it back into a text message, and it'll do that. And that's what this last part does, which is the decode function. So you give it your input song. If, for example, we give it like the other kind that had the message encoded, it'd turn it into a byte array again, and then it would extract all the bytes. It would take all like the least significant bit out of everything. And then this just converts it back into a text message. And then this part cuts out those filler characters. So if you have like 3 of them in a row, it basically starts indicating, okay, they didn't put this in the text message. This is just the extra bytes that we don't need. It's going to split that, and it's just going to print out that it decoded the message, and it's going to print whatever message you have. So it's not a very hard script to write if you understand wave format, and mostly just the binary. If you understand how to convert files into binary, this gets really simple really quickly. So another thing you can do, spectrology master. This was another open source thing I think developed by MIT, spectrology.py. This actually is what converts an image into a wave that allows you to see. So is this up? So a lot of this is just, you have your parser arguments, just take everything in. Then you have your actual conversion. It's going to open the image. If you gave it a rotate function, it's going to rotate it 90 degrees. It's going to make sure that all this stuff works correctly, and then it's going to actually get through this whole size. This whole thing down here, this is what's converting it into a wave. It's basically taking each and every pixel and associating it with a certain frequency or wave value. So that way it creates a whole wave based on the pixels in that image. So that way, and it arranges it so that when you would layer a spectrogram over it, it would actually show up as an image. And then it's going to tell, this program just tells you the conversion process, then it's just going to do all the rest of it. So I have a couple other versions of that I did for examples. Let me see. Oh, this one. Let me open this one. I will tell you most of these are memes because I decided to have fun with this. It is not. So you can see how this is a weird frequency. For whatever reason, it jumps really high. Let's just layer a spectrogram on top of that just to see. And move this away and pump my system volume again.
Nice. Nice.
Plug logo inside. This is exactly where it belongs.
So, do you have time for questions?
Yeah, got time for questions.
So, one of the biggest things for, like, image, for image setup that I run into problems with is that, it tends to be that, like, when I upload an image, to a website, to like share, distribute, things like that. Like particularly like a lot of like freely available stuff, what they'll do is they'll strip out a lot of like metadata, they'll change the image, and more often than not, that corrupts my stego. Have you tried the same thing with audio? Like if you were to like upload an audio file to like YouTube or something, do you think it would change?
How it sounded?
And like the spectrograph?
I have not tried that, but I'm pretty sure some of that would show up differently depending on how you did it. Sometimes it depends on the kind of program you're kind of using to convert an image into audio. So that program actually takes in the frequency you want to generate it at. I forgot to mention this, but you give it the input of whatever image you want, then you can tell it like the bottom frequency. So let's just say it's at like 13,000, and then you can give it a top frequency, put it around, I don't know, let's say 17,000. It's just going to generate an audio file at that wavelength. It's kind of hard to change it, the metadata. But what you notice is sometimes the image loses quality compared to the original. If you have a super detailed image that has so much random stuff in it, like a bunch of different colors and whatever, that's not going to transfer over very well when you convert it into an audio file, because you can't show different colors in wavelengths like that very well. You can show the wavelength itself converts to a different color every time, but having such vast variation where it's like you have red on the bottom, but then immediately a couple pixels up, you have blue, it's not going to show that right on a spectrogram. It's just going to try and make it into a static monochrome image. So that way it shows up properly in the spectrogram. So certain images you might find aren't going to work as well when you try and do this. But if you have like just a regular black and white image, it's going to show up a lot clearer than this, which is why the Hack UCF logo showed up a lot better than some others. Anyone else have any questions? Yeah. Yes. Spectrology. Spectrology. This original folder I just downloaded and then just never bothered to rename it. Yes.
And I'm guessing you can also just with using the iconography, you can just don't have the image to weight conversion without having previous weight class, right?
Yes, it'll take in the raw image and you can output it to, it'll by default, I'm pretty sure it goes to out.wav, this program. And it sounds horrendous, but it's just the raw image in a waveform. So
I know that certain games, I know the Portal 2 ARP,
Mhm.
before Portal 2 release, they had the different iconography of images that you would have to decode, and then it would show like different images from the game.
actually, another interesting one I had, anyone know the game Boneworks? Basically our Half-Life, yeah. They actually did some steganography in one of their audio files. So I have bone tones here, I just pulled it from the thing. I need most of the names to be displayed. So we have all of these. So if you own the game and you can strip the files or find them online, they have Opera de OSINT. So if we go into Sonic Visualizer again, we just open it up. Here, I did this. Bone tones. Opera de OSINT. If you listen, it's not going to sound like anything's hidden in it. It doesn't really sound like much. It doesn't really sound like much is hidden in it. A little weird. If you can kind of hear it if you were right next to it, but instead we can just layer a spectrum just to see it anyways. So this down here looks a little weird. They layered. You're listening to 98.6 KCCW. That is actually a reference to the developers' next game, Dead FM, where I believe it was one of their main characters runs a radio station, 98.6 KCCW. When this game released, this is in the raw audio files you can pull from the game, and they're already teasing their sequel game, Dead FM, which I thought was really cool. A lot of games like this, a lot of games in general will hide things in their audio files just for you to find. if you just know how to view a spectrogram or do a lot of other stuff. Another thing I forgot to mention, I showed you audio that's hidden in an audio file. To actually mix it, you can just use Audacity. Don't have a raw output file to use it with. Yes, but that's if you do it in an audible frequency range. Sometimes spectrograms won't display audio outside of the audible frequency range. So, and most audio as well, they hide images, very small segments, like in 1 second span, so it's not visible, and very low pitches, so low frequency, so you can't hear it as well, but it's still there. So if you want to do it, you can open just any regular audio file. Let's just open this, for example. So we have we just have regular September. This is just the raw thing that doesn't have any images encoded into it. I don't have a WAV file to put into it that has an image, but if we go to import audio, do not go there. Steganography, spectrology master, samples, and let's just throw beacon in here. So now you have your original audio and you have a new one you tried to import it into. You go to this and it, okay. This is an older version of Audacity where you can drag this along. In newer versions, if you try and do this for yourself, there's a little button right up here called time shift. That's what you're going to use to drag it around. In older versions, they have a little bar that lets you drag it around, but you need to click time shift if you want to move audio in newer versions of Audacity. But for example, we can take this, we can drag it to wherever we want. Let's just say here, and if we do file, export, let's just export it as a WAV, and it's going to be totally new. Stop here, get back into examples, and we'll just call it Rydia.wav. And then it's going to mix it and it's going to be exported as one file. This is mainly for studios, like you want to add an artist name, track title. If you're kind of making an album, that's what that's used for. You can just ignore that and hit OK. It's going to export it. So we don't need this anymore. That's how you can use Audacity to do this. We can go back to examples or back to Sonic Visualizer. We can open Rydia again, Rydia.wav. So you can see it looks horrendous because it basically force merged September with a new hand has touched the beacon. But if we add a spectrogram to it, we've merged Meridia's beacon into September, and it's also playing a new hand has touched the beacon for the entirety of the images that's on screen, because this is also that in default.
A new hand touches the beacon. A new hand touches the beacon. A new hand touches the beacon.
Definitely there. It's definitely there. It's really funny. But a lot of times, I find audio steganography a lot easier to detect than image steganography, because when you edit certain parts of the actual WAV file, whether it be binary, the actual frequency itself, or anything else, it leaves more audible traces that you can hear. At least for the kinds that are in the audible frequency range. If it's in the audible frequency range, you can hear some kind of distortions that indicate something's probably there that normally shouldn't. If you think something's there that's outside your audible frequency range, you can put it into Sonic Visualizer, view a spectrogram, and see if there's anything outside your audible frequency hearing ranges. If it's above 20,000, but there's a bunch of light that indicates there's a bunch of frequency up there, it means there's probably a song there, and you can probably lower the frequency down. If you want to try and learn Nyquist, it's literally a scripting language only used for Audacity. You can probably find out how to use that online. And you can just lower it back down to actually hear whatever that hidden audio was. But anyone else have any questions? All right.
Thank you, Jackson.
Thank you.
That was awesome. All right, so on to the main topic. We're going to go over search engines and OSINT. Weaponized search engines to your benefit. Jerry?
So first we're going to talk about DuckDuckGo. So if you're not familiar with it, DuckDuckGo is a powerful and privacy-oriented search engine. It lacks curation algorithms, or what DuckDuckGo terms as the search bubble, like search engines like Google, and it has two really powerful features: instant answers and bangs. Instant answers are kind of a leftover of an open source project called DuckDuckHack, where community members were actually able to submit features to DuckDuckGo. Because of this, there's some obscure stuff that will just appear as an instant answer, such as crafting recipes for Minecraft or a cheat sheet on how to use Vim correctly, which is super useful because you can use these community created resources to like get a better search quicker and faster, even if you're not doing OSINT stuff. And also it has a feature called bangs. So bangs are a way to, within a search query, redirect the search from one site to another almost instantaneously. This is especially useful if you have DuckDuckGo as a default browser, because even if you're not going to use DuckDuckGo for OSINT, you can quickly redirect a search from one site to another. So you can quickly do a Twitter search and then 5 seconds later, run it on LinkedIn. So I'm going to actually give you a demo of that in a second. But there's also another thing that DuckDuckGo sometimes is useful for. Sometimes it tends to pick up files that are not text, but it reads it as text. And because of this, sometimes you can search random characters in DuckDuckGo and return binary results. It's also very customizable. Am I sharing the whole screen? Okay, so before I get to Baidu, I'm going to show off some DuckDuckGo. So does everyone in chat see this? Okay, so I'm going to go to duckduckgo.com, and actually, Firefox kind of auto-completed it. So this is the main interface in DuckDuckGo. So you just get thrown here, and let's just say I want to search how to craft a diamond pickaxe. Let me, and did they remove it? They might have. Demo gods are not on my side. But on top of some stuff like that, you can also do like a programming question will search Stack Overflow with an instant answer. So how to integer divide in Python. There should be is there not? Thank you.
In Firefox, it might be. Yeah, Firefox is a text on my default.
Shouldn't. There we go. So on the right side, you can see this kind of like instant answer right here, and you can kind of drop down and you don't have to go to the website to get an answer to a question you're asking. And then this will pop up in sometimes just a search you're doing. It might pop up for a shopping result or something like images. In addition, like you can also customize DuckDuckGo right there. And then you also have bangs. So let's just say I want to do this exact same search query, but instead of on DuckDuckGo, I want to do it on Stack Overflow. I'm going to put an exclamation mark right before the word Stack Overflow and click enter. I'm on Stack Overflow already, and it just has me do a captcha because, yeah, and right now I just did a search on Stack Overflow. I could do this for a bunch of different sites. You can actually see a list of all bangs at duckduckgo.com/bang, and there are 13,565. So let's just say you want to do something like Showdown. You can do exclamation mark Showdown. Let me see if they ever added that. They didn't. And then you could do like a Baidu if you want to search on Baidu, which we'll talk about in just a moment. So that's just some of the things you can do with DuckDuckGo. For the binary demo, unfortunately, I don't have a great search query prepared for that. So we'll do that in just a moment. So another search engine is Baidu. So Baidu is a Chinese language search engine, quite similar to Google in scope and execution. It allows you unlike Google, which mainly surfaces the English speaking and generally non-Mandarin speaking internet, it allows you to search the mainland Chinese internet. This is super useful because Google usually doesn't index Chinese websites. This is because of a mix between the Great Firewall of China and legislation that prevents them from operating in the country. So if you wanted to search behind the Great Firewall of China, or just to see what's happening in Chinese speaking World Wide Web, you can use Baidu to figure it out. Also, like Google, Baidu has way too many services. And I think unlike Google, they don't kill them off every other day. You got like blogging, video hosting to compete with YouTube, images, translations, academic search, news, which is, I hate to say it, probably PRC propaganda, music, car reviews for some reason, and enterprise search, which might be familiar to you if you have used Bing for that use. So I'm going to pull up Baidu. You can access it at baidu.com or baidu.cn, and this is the interface. Now, just a disclaimer, I don't know Mandarin Chinese, so I'm going to literally not know what is on screen. And actually, if you put it through Google Translate, it will break. So I am just going to use the pretty much whatever this default search is. And you can actually see it pulls up a bunch of app results, a bunch of stuff that unfortunately I can't understand. And you know what, I'm gonna, so yeah, you got a bunch of results. If you wanted to, I'm gonna see what HoloLive returns in Baidu, which if you are not familiar, there was a controversy with this specific group because they did not want someone accidentally admitted to Taiwan being a country. So, and I believe this is a blog post about it on Baidu. And then, yes, it's in Chinese. I can't read it, but so what? You can also see other services that Baidu operates if you go here. So this page I know can be Google translated. So I'm going to go to DuckDuckGo again, use a bang to get to Google Translate to translate this to English. And this is a list of all the services Baidu has. So you could see you got enterprise search here, their search app, video aggregation platform, and yeah, actually, there might be one search I want to do. See what the results for ByteDance are, which is the parent company of TikTok. And then you can see it pulls up this like news article and has a bunch of company information, which if you want to get some information about like maybe a company that's operating in China or has operations in China, this might be super useful. Actually, just for funsies. I think they should, yeah. Here we go. Just kind of reference the internships that are open. Since Blackstone does have operations in China, you can view some information about the company in Chinese. So yeah, that's about it for Baidu. I'm now going to pass it over. Someone can do Yandex, which is just Russian Baidu.
Yeah, Yandex is basically just the Russian version of Baidu, which is just the Chinese version of Google. It's the exact same thing as Google, has a lot of the same services. Most of it's generally the same. It was originally Russian Google, and it's like yandex.ru if you want the Russian version. They released a global version, which is yandex.com. That has most of the options are available to you in English. It uses local SEO, local search engine optimization. So it'll give you results more related to what's around you. It takes information, like your location gives you more like English Google index sites, stuff like that. But if you instead decide to use, the yandex.ru, which is the Russian version, everything is for one in Russian. And two, it'll give you more Russian index sites. So a lot more that are kind of like specifically like Russian websites, a lot of their news, anything generally just from there is you're going to find on yandex.ru instead of yandex.com. What? Yeah, and this is like images. So what I personally like to use Yandex a lot for is reverse image searching. They developed a specific AI a few years back called Cyber, SIBIR, like Siberia, which is, it's actually how it's spelled, you can look this up. It's an AI that helps their reverse image search engine more accurately give you results. So you know how you reverse image search with Google, you generally get some more generalized, generic results, not exactly the exact thing you were looking for. Generally, Yandex, their reverse image search Cyber, will give you more exact matches for what your image was, kind of where people got it. So I personally like to use that. So let me go to here. Index.ru, we'll go to the Russian version. Everything is in Russian. So we can look up. Yeah. Use cookies, don't care. Sticky keys, no. Alexei, what was his name? The opposition leader. I don't know. What was his name? Shvenko. We just search Alexei. See, everything's in for one in Russian, but as you keep scrolling down, you see what? .ru, or it's going to give you some, like Wikipedia pages are going to be in just Russian, but they're still .com. But they have a lot more that are just like the Russian index versions. So that's mainly what you can use if you, for whatever reason, understand Russian and want to search their websites for their things. So we can go back to Yandex. All right, no idea what. All righty, so their image searching, which was, so they have videos and then images is next for whatever that is. So you can search for whatever you want, but this icon is what you do to upload it. So I'm going to go to yandex.com because I do not remember exactly what. Alrighty, Yandex, excuse me. If I could please, did that correctly? Yandex.com. Yes, I'm not a robot. So now we know what that is, other than caption. So then this has the reverse. Everything's in English this time, but image is at the front here. So we can enter an image URL. So let me just slide this a bit so I can get everything. And I don't know, what's a random kind of distorted image I could probably search for? No idea. No.
No.
Probably do that. Hack UCF. We'll take this one. And no, didn't want that one. Copy image link. Enter an image URL. Search it. I know. It's annoying. I could probably use this one, right?
Yeah.
Copy image link. That should work. I ended back up here. Put your image URL, search. Of course, it knows a little more metadata, but brought up a ton of things that look the same, but the first is it's going to give you that. So many of these, because a lot of them use the exact same logo, but the first result is going to be what you exactly had. So some of these might be a little weird just because of how generic this logo is. But
You just in our logo.
diss in the logo. Yes, the standard cybersecurity logo. All right, but that's basically
That's the whole point, like the colors are matching, the shapes are matching.
as you can tell, their AI had trouble with this because so many of them look the same.
Yeah,
They
like
should.
you got like Binance, which is like almost shield shape and it's the same color. You got like roof shield because same feel.
Mhm.
Like pretty solid.
Very good AI. You have to trust me. Many sections. Yeah. Google image search. Just go to Google Images. This paste image URL. Search my image. Give. Yeah. So visually is. Yeah. Look at this. Compared to Yandex, look at everything that we got for the exact same image we gave. We gave this and we got
Nothing.
nothing. Half of these are Another language, I'm pretty sure it's German. So, of course, their AI didn't exactly get the match. It didn't find a lot more hacky CF, but it found a lot more that were very similar because same color scheme, same kind of pattern, a lot like that, compared to Google, which gave us this. Very accurate. If you ever want to reverse image sort of thing, probably use the index over.
Does the index also do like image recognition as well?
Yes, it does, because of how their AI works. It basically will break it down into certain squares and start piecing together, start searching for whichever one matches. So instead of just kind of like taking the whole image or specific bits and comparing it to whatever seems to match, breaks the entire image down, certain squares, pieces them together, and just tries to find the closest match with each individual square on an image it's comparing it to. Please do. It'd be very
I'll
interesting.
send the screenshot in the Discord and if there's any interesting results.
Please do. And yeah, next is Google Dorking.
All right, so we kind of covered this a little bit in an earlier meeting, but we didn't go into like a lot of detail. So today we're actually going to go over some specific operators and talk about why exactly it is that you would want to do some of this stuff and like, you know, how to make use of it. Just quick terminology, Google Dorking refers to like using like specific operators that Google has functions built into for your own usage instead of trying to go through their interface to do it. We're going to go over a bunch of those. Just try to keep in mind that like some of these operators do work for other search engines because it's really, really useful. I know that DuckDuckGo has nearly a 1-for-1 with what Google's using now. So you can still use a lot of like the and or wildcard operators. File type doesn't work, but extension does. We'll talk about that a little bit. Another thing is that Google does tend to change and deprecate features pretty often. That does include Google search. So just because something works today doesn't guarantee that it'll work tomorrow, and you should probably try to keep up to date with this stuff because it changes every couple of years. First things first, we can get started with in title and all in title. It searches for occurrences of keywords in title. So if you were to type in title : no space directly the keyword that you're looking for, what it's going to do is it's going to search all of its index pages for that keyword in the title of the page. If you're familiar with HTML, you'll kind of understand a little bit more of like what that means. All in title is just a string of keywords, and those will all be searched for inside the title space. In text or all in text is similar to in title, except it's in the body of the web page. What that'll do is it'll look for that specific keyword anywhere inside of the body of that given page. In URL or all in URL will search for the specific keyword or occurrence of keywords in the URL. These all can be like used in different ways to kind of pin down exactly what you're looking for. And they can also be used in combination with one another. Sorry, a little hiccup there. So you could do an in URL search for a specific keyword and then follow it with an in text search. So if you know that a website might use randomly generated strings of characters in between like files or folders or things like that, you can throw in other operators to find specific pieces that are identifiable, right, to defeat some kind of obfuscation. And then do an all in text to find a specific string of characters you might be looking for specifically. Maybe you're looking for a report by name, maybe you're looking for a specific date, maybe you're looking for someone's name, something to that effect. And if it is listed, that's how you'll kind of pin it down. Continuing on that, we've got file type or extension. Google does have a preference for file type, but ext or extension will work. DuckDuckGo does not like file type. I don't think it recognizes it currently, but it will recognize extension. And you can do this by just file type. You can put it in quotes, but you don't really need to unless it's a string of characters that you're trying to like ensure show up. For example, you do file type .pdf and then in text body or all in text, you could say like payroll. And then you could end up finding a PDF on a website that talks about payroll. You could use an in URL to say like Facebook and then find Facebook's PDF payroll. And that'll list every single thing that Google has indexed for that. Cache will show you cached versions of pages that Google has. Once again, the quotes aren't required here, but they can be useful on some occasions. So cache and then the specific page that you're looking for will just immediately return any cached pages that Google has. Sometimes it's useful to use the Wayback Machine if you're looking for something that happened like that happened to be indexed a while ago. But if it's been recent in the last like year or so, there's a good chance that Google's actually got that cached for you. And specifically like when certain web pages go down, this can be helpful to just kind of like bring back the last time that Google cached it. I know there have been plenty of times where I go to connect to a website because I'm trying to get something and their web server's gone down. They've been hit for something and the cache is still up and I can get all the information out of that I need. Define is more just like for fun, but doing define and then any keyword following it, it will attempt to locate that specific keyword in the dictionary and immediately return the result. A lot of Google's other services use similar features to this as well. They do get deprecated pretty often, but you can do things like location for very specific location-based results. If you're looking for like a news report from a specific city or a state, you can do location to do that. You can also do weather, not like necessarily that applies to cyber all that often, but sometimes it might. If you do weather and then any string following it, it will look for any weather results related to that. Talked about it briefly before, but cite is essentially, it's going to restrict all of your search results to things that are from that site. So if you were looking for password hashes from apple.com, and you do cite:apple.com space password space hashes, and then in URL.txt or dot something, or file type dot, whatever extension you think that might be related. And if it exists, if Google's like indexed it, it'll show up. It's not likely that Apple will have that kind of stuff exposed, but a lot of smaller companies, specifically ones that can't afford to have audits, they tend to not know exactly what is being indexed and what isn't being indexed. And that's a great way for you to turn up stuff that they might have missed. Another fun one that I wasn't aware of prior to this, even though I've done a lot of Google dorking, is around open parentheses, a number, and then close parentheses. And what that allows you to do is basically say that you want to define or you want to refine all of your search results to have 2 or more keywords within certain words of one another. So the example is Apple around for iPhone, which will limit all results to have only Apple followed by up to 4 words and then iPhone. Anything outside of that, it just won't return. This can be really useful when you're trying to follow a specific sentence that's used, usually like when you read like a report for like a breach or something that like comes out. You might have a very specific quote given by somebody, and you might want to follow on a certain amount of number of words just to see like where all that interview was posted from. Even if you're trying to like locate the origin of that report, you can just take a specific set of that interview and then drop that in there, and then you'll get back those search results pretty quick. Quotes, pretty basic stuff. Everyone I think knows that one. It just restricts the search results to show contained quotes. It returns search results that have the contained keywords in quotes. Once a while ago, Google also had the plus sign as an operator that you can use. That's been deprecated. It actually doesn't do anything. Like it's an alias for quotes now. So you just need to use that. You do have the pipe or capital OR as one word, which is an inclusive or. It shows one thing or the other. The example given is cite facebook.com or cite twitter.com followed by whatever keywords you want, and it'll return one or the other or both. You've got the and operator, which is an implicit and for all Google searches. So what that means is that if you have like keyword space, keyword space, keyword, there's actually a hidden and in there every single time. So if you're searching for Apple iPhone 2020, right? What it's doing is Apple and iPhone and 2020, right? You can control that a little bit better by using parentheses and bracketing to kind of manipulate what search results are being shown and what aren't. So it's always good to know like when the and is implicit. So getting some combinations going, you can see where this kind of all fits together, and your mileage is going to vary based upon like what it is you're searching for and how familiar you are with logic and with putting this to use. But for instance, if we wanted to combine and or operators together, we could do cite facebook.com or cite twitter.com in parentheses and in text login. And what that's going to return back to us is anything that contains the word login inside the web page. So if we wanted to like go a little bit outside the box on that and maybe like abuse this, you might want to do cite facebook.com or cite twitter.com and in text admin or configuration or settings. And you can see how like that can kind of expand around and get you to something that might not be public facing or shouldn't be public facing pretty quickly. The asterisk or star is a wildcard operator that basically allows any keyword to be substituted in its place. So cite facebook.star means any Facebook registered domain, right? Whether that's com or co or de or whatever is going to show up. You can also restrict that by doing a minus operator, which forces an exclusion of the following operation of like any operations that follow it. So you do cite facebook.star space minus cite facebook.com, and that's going to show you every existence of Facebook dot something that does not end or does not follow in COM. So if you're very specifically trying to find a web page that shouldn't exist or isn't published or isn't like high priority in Google search engine, that's a fantastic way to do it. Moving on to Bing real quick. So Bing has existed for a while, and it's useful in some context. One of the great things about Bing is intranet searching. Being that it is a Microsoft product and it is internal use and prioritized by Windows and Microsoft services, it does have the capability to index private networks, specifically like non-public facing networks that are built on Microsoft services. This means that in some cases, you'll be able to search via Bing and return a faster, more accurate search than an exterior search engine because it's actually searching inside of your company network or your private network. It's limited in use, but in the right situation, it's incredibly useful and definitely can be relied on. The finding of Google to search things is what I like to use Bing for. Also, most people do. Statistically, according to research, Bing is most often used to find Google to do searching, so that's good. Image and video searching on Bing, actually, to say some really good things about Bing. One of the great things that Bing can be used for is doing image and video searching. As we talked about a little bit with Yandex about reverse image searching and why it's so much more powerful in Yandex than it is in Google, is Google does a very good job to try to diffuse searching to not be as specific as you might want it to be. And Google does a really good job of insulating you in searches that it thinks that you want, not necessarily searches that you actually are looking for. Bing doesn't do this. So when you do an image search with Bing, it's trying to match as close to what you're searching for as it can. And more often than not, that can actually return a closer example of what it is that you're looking for, even if you don't know exactly what you're looking for. Same thing with video. Because Bing doesn't prioritize YouTube, although it will return a lot of YouTube searches, you are able to use Bing to find a lot of videos that exist that might not be Google products. This also goes to all other things that like are Google services. Bing doesn't get paid money whenever it returns a search for like a Google service. So it's going to show you what it wants. Now, more often than not, that's going to be a Microsoft service. It's probably going to be worse, but it's not going to be a Google search and it's not going to be a Google service. And sometimes that's really, really helpful. Another thing not to forget about is depending upon your use case, what kind of career you're going into, what kind of stuff that you do, you may find yourself in situations where you kind of have to be stealthy. You might be interacting with a company that explicitly doesn't allow outside traffic to certain sites, like Google, for instance, or DuckDuckGo or Yandex. If you are relying on, let's give a great example of like, let's say that you really love Baidu. It's your favorite search engine. You just like live that all day long, just nothing but Baidu. And you're inside a computer in a company that's in a restricted network, right? You're not supposed to be there. You're doing some kind of evaluation perhaps, and you need to perform a search. You need to reach out, you need to get a redirect or something. And you don't have that information at hand. You can't necessarily just like default to like your standard operating procedures. You can't use Baidu in that situation, because the moment that you do, you're going to flag in the system and you're going to get discovered, right? You're going to kind of like tip your hand there. So you might need to use Bing in that case, just because Bing is going to be the backbone of what every like Microsoft operating system is using. Like those queries are going to certainly fly under the radar way more often than an errant Google search or an errant Yandex search or Tenai or Shodan. I mean, there's so many different ways that could go wrong, and you might like that might just be that little bit of edge that you need. Even if you found out eventually, the longer that it's going to take someone to discover where your trail starts and stops, that's pretty valuable. Next thing, gonna talk about some meta searches and meta searching. This used to be something that was like really, really popular. Google actually used meta search and keywords in meta tags to prioritize sites in the earliest days of its search algorithms. However, due to some rampant abuse by a lot of site admins to do SEO and to kind of push sites to like higher and higher levels to get more customer traffic, keywords kind of got devalued and deprioritized. That doesn't mean they're not useful. It can definitely be it can definitely be a tool in the tool bag, but it's not as common to dump a bunch of information into meta tags, and more often than not, site admins are going to not try to put a bunch of information into tags that they don't want publicly facing. They don't want that information indexed. If they're trying to be sneaky, they're not going to be like initially like broadcasting all the keywords to be found. That doesn't mean though that certain people are not going to put that stuff out there. Meta tags still exist, they can still be used, and sometimes they are just a great means of transmitting information. So you can use a variety of search engines to do meta search very specifically. They can also index specific meta search, not across like just one website that you might be looking for, but across a whole host of like hundreds of thousands of websites to find very specific keywords and tags. So definitely keep that in mind. Next thing we got up here is Shodan, and we're gonna have a quick demo by Ryan.
All right. So I'm going to briefly talk about Shodan and do just a quick demo on it. Shodan is essentially the Google for servers that are on the internet. What they do is they scan pretty much, they scan every internet-facing device and allow you to see what ports and or services are available on that specific device. It's really, really good if you're doing security investigations. It's great if there's a security breach and you want to see what exactly the attack came from, or if you're doing an internal audit and making sure that certain things are not exposed to the public internet. Right, so this is the main Shodan page. Essentially, it works the same way as Google. Up here, we can just put in an IP address and see what's running. So this is one of Google's servers. As you can see it's running in Miami. It's owned by Google. Its ISP is Google. We have the security contact information, and we have the open port as well as the response that the server gave back.
certain servers you'll look up and, in security investigations, it'll actually tell you CVEs of the server. So these are vulnerabilities that the server is experiencing and has. We can also do tags and search for things like you can with Google, as Daniel showed us. In this case, I did a search for port 5432, which is the default Postgres port. And this shows me all of the Postgres servers exposed to the internet. We can see the majority of them are in the United States, followed by Poland and Germany. We can see exactly who is running these servers. So in this case, Google, Amazon, which would make sense as their cloud providers. And then we can see the top products that are used as well as the OSs. There's a Synology open to the internet. That's cool. Don't you love when you expose your NAS? The other thing is because it scans everything on the internet and people don't know how to configure things correctly on the internet, it leads to a lot of interesting finds. For example, pretty much for all of time on Shodan, the top voted thing search is webcam. And it will take a second to load, but essentially this is every webcam that is exposed on the internet because people don't know how to set up things correctly.
Not just webcam though, it's any device that is considered a webcam.
Yes.
So your security system.
Fun fact, Linode's on here, which is a cloud service provider. I don't know if that's just like they're building cameras or because like you're not running a camera in the cloud, it's got no camera attached to it. Yeah. Cool. There's a honeypot tag?
Yeah, look at the tag.
Oh yeah, this is
That's the popular one. A lot of people will put fake webcams up.
yeah, so this yeah. So for people who haven't heard of the term before, a honeypot is a server that is designed to essentially just attract hackers into your network so you can catch them and you give them just fake resources, hence the honeypot. I'm not an enterprise user, so I can't actually filter by honeypot, which is cool. But it is again one of those things that you can search for because they have a tag system.
They can also use that data if you're not using VPN. Using public security, take your IP.
Right. I've used this at work before, kind of helping out the SOC team with different firewall logs that they've seen, kind of figuring out what the different IP addresses are. Most of the time, surprisingly, it's Google or Facebook, but it is a very good tool for an use case in that. Also, fun fact for anyone who's interested, you can sign up with your EDU email account and get the base pro account for free. That doesn't limit your searches, and I think it gives you basic access to their API. So you can just sign up with your UCF email and they'll give it to you for free.
Thank you, Ryan. Yeah.
That's all I have.
Another couple of things. You can actually usually watch a lot of those webcams directly from Shodan, or at least you were able to a while ago. Doing a lot of IR and stuff, tracing down IP addresses. You don't necessarily always want to do that from your own machine, even if you have the ability to connect to a VPN to a random server somewhere, or just to proxy. It's best just not put yourself out there. Running through Shodan runs through all their servers on pre-indexed information, so it's about as passive as you can get. Like Ryan showed, it exposes the ports that are available on that server. So we saw 80 and 443. That tells you quite a bit about what active, what is active on that. Using the port tag, you can also narrow that down to direct IP addresses. You can also filter by ISP service providers, IP ranges, all kinds of stuff. Shodan is an incredibly powerful tool. And if you aren't familiar with it, you should at least take a couple of hours to kind of play around with it and see what's up, because there's some pretty neat stuff out there. All right, so that concludes our meeting for tonight. I'm going to go ahead and remind you that operations is totally a thing. And if you want to come out and you want to help, run the club, you can meet with us and on Tuesdays at 8 p.m. You don't have to have any qualifications. If you just want to like do a thing, you're excited about something, you just learned something, you want to learn something. We're always looking for more help running the club. Hack UCF project's gonna kind of iterate through real quick. Infra dev besides Michael, your announcement. Do y'all have anything you want to share?
I'll put in this one more later, but last Tuesday was our last internet meeting for the semester.
Okay.
Everyone focused on their class and finals. Again, you know, semester people. You continue to work on them, but we'll be good for it, but there'll be no more regularly scheduled for meetings until now.
Gotcha. All right. So for those in chat that couldn't hear Michael, last week was the last formal in-person infra dev crew meeting. So if you are still interested in getting on that project, you can hit them up in Discord. If you have work that you've been doing, you can still continue doing that, and they're still gonna be active in the Discord, just not meeting until spring semester starts officially. So there's that. Web dev crew, we got anything going on there? Anything special involved? No?
I'm pretty sure it's like just pretty much stale right now.
Gotcha.
Nothing to be done.
All right, and design crew, yeah, there's definitely like things to get designed and to do, but if you have design talent and you want to put that to work, you should definitely put some t-shirts out, put some hoodies out, put some merch out, and maybe win a prize. If you are not on the mailing list, you join the mailing list. If you haven't checked out our shop, buy our merch. If you haven't joined the Discord, why not? You should do that. And we're here on Twitter. Thank you very much. We appreciate you, and we'll see you next week.
I thought I was earlier, not like, so.